Okay, welcome back. This is the second part of the video. We left off talking about how perimeters of similar figures are related, and looking at the work that we've done, we see that the perimeters of the ratio of the perimeters are the same as the ratio of the sides. So ratio of perimeters is the same as the ratio of sides, ratio of perimeters. Okay, is the same as the ratio of the sides. But how are the areas of similar figures related? Let's look at this. See if you can see any relationship going from 3/5 to 9/25. Okay, what's the relationship of 3/5 to 9/25? The next one, 1/3 to 1/9, and the next one, 1/8 to 1/64. Do you see a relationship between these numbers? Well, if I square this, 3 squared is 9, 5 squared is 25. 1 squared is 1, 3 squared is 3, 8 squared is 64. So the area ratio is the square of the perimeter ratio. Okay, so it would be like 1 over r, I'll put r for ratio, squared. Now the same thing's true, so if I wanted to go the other way, if I was given the area ratio, I can get to the perimeter ratio by taking the square root. So going this way, you square it, we do ratio squared, and going this way, you take the square root of the ratio. Okay, that says ratio squared. Let's do a practice problem, and hopefully you'll be clearer about what we see. Okay. Your teacher enlarges the figure below so that the area of the similar polygon is 900 square centimeters. What is the perimeter of the enlarged polygon? Well, the area of this, we'll call this the small one, is 100, and the area of the enlarged one is 900. So we can see that the relationship is 100 over 900, which reduces to 1/9. So the area ratio is 1/9. So then what is the perimeter ratio? Perimeter ratio. So if I had area and I'm going back to perimeter, I'm going to take the square root of 1/9, and that equals 1/3. So this is my perimeter ratio. And why is that important? Because I can find the perimeter of the small figure. Okay, we're going to add all this up. We're going to go 10 plus 13 is 26, 27, 28, 29, 30, 38, 39, 40, 41, 42, 42 plus 5 is 47. So the perimeter is 47. And remember, I got that by going 10 plus 13 plus 4 plus 8 plus 4 plus 5. I got 47. But now I want to know the perimeter of the large. Well, that's the missing information. Let's call it, I'm sorry, we want to know the perimeter of the large. So I'll just call it P, perimeter of the large. So if I know that I can set up a ratio. The ratio I want to use for perimeter is 1/3, and that's going to equal 47 over the perimeter that I'm looking for. So all we're going to do is do cross products. P times 1 is P. 47 times 3, I need a calculator for that one. 47 times 3 is 141. So that's 141. Let's just make sure I added all that. Okay, so let me just check my work. This should be a 44, right? I added that wrong. That's a 44. So that just means I'm going to make this a 44. And then when we multiply 44 times 3, we get 132. I did a little mess up, but you guys are smart. You got this. So I add this up. 10 plus 13 plus 4 plus 8 plus 4 plus 5 is 44. The same process, except instead of a 47, it's a 44. And it's the ratio of the perimeters is equal to 44 over P. How do I know that I put the 44 on the top? Well, because everything about the small figure is on the top, everything about the large figure is on the bottom. And I want to be consistent about that. So let's look at the next problem. In the next problem, we have to assume that A and B that these are similar figures, and the ratio is 3 to 4. So the ratio is 3 to 4. Then what is the ratio of the perimeters of A and B? The ratio of similarity, that's talking about the ratio of the sides, right? The ratio of similarity. Well, the ratio of the perimeters, perimeters is the same. So it's also going to be 3/4. If the perimeter of figure A is P and the linear scale factor is R, what is the perimeter of B? Well, let's see. The similarity figure is 3/4. The perimeter is P. And so I want to find out what the linear scale factor is. The linear scale factor is R. Okay, when they say the linear scale factor is R, they're saying like it could be feet, it could be inches, it could be something. That's just the scale, what we're measuring by. We're measuring by R units. Okay, so I actually want to find out what X is. It's going to be in terms of P. So we're going to do cross products. 3x equals 4p. And we want to solve for x, so we divide by 3. And we're going to get x equals 4p over 3 r units. So if I said that this was feet, it would be feet units. If I said it was inches, it would be inches units. R just represents whatever it is that we are going to be talking about. Look at the next one. If the area of A is A, and the factor that we're going to use is still R, then I don't like how this is worded, but we'll just say like this is feet or something. What is the area of B? Well, if the ratio is 3/4, then to get the area ratio, we're going to have to square it, and we get 9 over 3 squared is 9, 4 squared is 16. And if the area of A is A, again, we want to find out what this is, what the missing B area is. So we're going to do cross products, and we're solving for x. So we're going to get 9x equals 16 times A. We're cross products, that's how I did that. We're going to divide both sides by 9, and we get x equals 16a over 9 r units squared, because this is area. All right. Kind of a little weird way it's presented. It's more theoretical, but that's how you do it. I walked you through it. It's not that big of a problem. The biggest thing from this lesson is if I give you the similarity factor, of 2 over 7, let's just say, then if you want to know what the perimeter ratio is, and you want to know what the area ratio is, okay, what do? Well, the similarity factor or the sides, right? The sides or similarity, it's going to be the same. So that's going to be 2/7. The area factor, you're going to square it, and you're going to get 4 over 49. This is the key of the lesson, the thing that's going to be the most important. All right? Hopefully you understand that and bring your questions to Zoom.